Hi, it's Carly McAvoy back again to teach you about division. And division is the hardest operation of the four. Remember the operators addition, subtraction, multiplication, and division. We've already done addition, subtraction, and multiplication. And then we did some other stuff in there, and now we've got to face division because we can't really move on until you can divide. Even in the last lesson we divided a little bit by 2, but we're going to be dividing by what we call single-digit divisors today, and learning the terminology and doing some word problems with division. And then the next lesson we'll do even harder division problems with 2-digit divisors and that kind of thing. Okay, so when you have a division problem, first of all, I want to say that there's more than one way to write a division problem. Let's say I want to say 20 divided by 10. I could write it that way. I could write 20 divided by 10 as a fraction. That's another way to write division, means the same thing. And I could also write 20 divided by 10. When that division symbol that I just drew, this one that looks like half a box kind of, that's really hard to do on the word processor. And so if you printed out your practice worksheet like you should have done, you'll see those division signs look a little weird. But I did the best I could, but when you see those, bear with me. They kind of look like this on your worksheet. They don't quite reach each other because that was the closest I could come to making them look like a division sign. So you'll see that. Maybe we'll improve those and then you won't know what I'm even talking about. When I have a division problem, I have a divisor. That's what I'm dividing by. And I have a dividend. That's what I'm dividing into. These words sound a lot alike and people get them confused a lot. It also sounds like the word difference, which is a subtraction problem, which is something totally different. But you always have a dividend and divisor no matter where they are in the problem. So 20 is the dividend and it's on the top here. And 10 is the divisor. And 20 is the dividend inside, and 10 is the divisor out here. No matter which way I write those, the dividend and the divisor they retain their same name. They're dividends, whether they're first in this format, top this format, or underneath in this format, the dividend is those 3 places. And the divisor is always what you're dividing by, regardless of which way that you write that. The division operator, I'll circle in red. Of course, the one you start off learning first is that division symbol. That's the operator for division. But this also, this fraction bar, that's the operator for division. And this right here, that symbol, that's also the operator for division. So there's different ways to show the operator. When you have an answer to a division problem, so let's say I have 105 divided by 10. 10 goes in there 10 times with a remainder of 5. We'll see how to do that problem in a second, but I want to give you the terminology. In this problem, which number is the dividend? Hopefully you said the 105 because the dividend in this format is always the one that's underneath. Which one is the divisor? Well, the divisor is 10 out here. What is the answer to a division problem called? That's this, and that's a quotient. Q-U-O-T-I-E-N-T. We say the quotient. Find the quotient means do the division problem. The R5, that's one way to state the remainder. We're going to look at other ways to talk about the remainder. But those are the terminology that you need. Dividend, divisor, quotient, and remainder. Those are all 4 new vocabulary terms that you need. The quotient is the answer to a division problem. The remainder is what's left over. The divisor is what you're dividing by, and the dividend is what you're dividing into. So all four of those terms you need. No matter which format they're in, you can still see that. I could have a problem. I don't know why that happened. Let's say I did 17 divided by 3. When you're doing something with a single digit divisor, 3 is a divisor here. I have to say 3 doesn't go into 1, so I don't put anything about the 1. But how many times does 3 go into 17? If you're not sure, try it off to the side. Like, what about 3? What about if I went 4 times? Well, 3 times 4 is 12, and it would go more than that. What if I put another 3 on that? 12 plus 3 is 15. That's good. Because if I added another 3, I'd get 18, and that's too much. We only have 17. So it can't be that it goes 5 times. It could be that it goes 6 times. It goes 4 gave me 12. 1 more gave me 15. So I think it's 5. It's okay to guess and check here. I have no idea what's happening on that. It's okay to guess and check, but so we're going to say, what about 3 times 5, which is 15? I think that is how many times it will go. So 3 goes into 17 5 times. 3 times 5 is 15. You multiply those two together and you put them down below and subtract. And then 17 minus 15 is 2. Notice that 3 will not go into 2. So that's my remainder. And as you saw over here, I could write it this way, remainder 5. And you have to talk to your instructor about what they're interested in for you, how you want to write it. But I know the test that you have to take to get into Math 90, you have to write it in what they call fraction form. So that's what I'm going to do a lot of, so that you get practice of that for that test. When you have 2 left over out of 3, you write it 2 out of 3. You had 2 left over and you were dividing by 3. So that's another way to write remainder. So in this problem, let's just do some labeling here. And I don't know what this little rectangle is about, but I'm going to clear it. Oh, don't want to do that. I just want to clear this object. I don't know how. Okay, we'll leave it on there then. I love it there. 3 is called the divisor. 17 is the dividend. 5 is the answer, which is the quotient. And 2/3, in a different way, is the remainder. A different format is the remainder. So I still have my divisor, my dividend, my quotient, and my remainder. Even when my format is as a fraction, that's still considered a remainder. So you can look at kind of all the things I have up here. I've got the same terms written over and over and over. I'm not adding new terms each time. But each of these problems look a little different. Okay, so you have the terminology. That's your first 3 questions asking you to label the remainder. In some problems there is no remainder. That's just how it is. And I don't know how to get rid of this. Well, I don't know what it is. Anyways, let's just move on and we'll just have that little rectangle in our lesson. One thing I want to talk about for division is that you can never divide by 0. This is a big no-no. You can never divide by 0. Another way to say that is 0 cannot be your divisor. Okay? It could be your dividend, but it cannot be your divisor. It cannot be that number on the bottom. Okay? It can't have it. So, if you have something like 20 divided by 0, you can't do it. And what you say, what the answer is to that problem is undefined. It's a new vocabulary word. Maybe you know the word undefined, but for math you need to say it. So some people say, well, can I just say it can't be done? No, the terminology is undefined. That's what you need to say anytime they're trying to divide by 0. So, 32 divided by 0 is undefined. 175 divided by 0 is undefined. I put 0 in the 3 different places where a divisor can go. It can be the second number, underneath, or outside. Any of those, they're all undefined. On the other hand, if you have 0 divided by 12, that equals 0. There's no rule that says 0 can't be your dividend. That's fine. It cannot be your divisor. It's fine to be your dividend. 0 divided by 7 is 0. 0 divided by 253 is 0. You can divide into 0. You can't divide by 0. People get that confused all the time. One way to remember when it's in this format is to say under is undefined. If the 0 is under, then it's undefined. Under is undefined. In this format, 7 is under, so that's not undefined, that's 0, right? So remember, you cannot ever divide by 0. It's not like, oh, when you get better at this, you'll learn how to do it. You're never going to learn how to do that because nobody can divide by 0 ever. Let's talk about a division problem. I am going to change these. You have division problems on here. You have 6 to do. 2 of them are dividing with 0, so we just went through those 2. But the other ones I want you to rewrite and then do. And so I'm going to change them a little because I want you to practice the ones with me and then practice the ones on your practice sheet. My dividend is 473. And let's divide by 7. Okay. When people start doing division, they get frustrated easily because they don't know. It's some guess and check involved. That's how it goes. You have to try something. If it doesn't work, try something else. The better you are at multiplication, the easier division is. So the better you get those tables down, you'll be better at this. But what you should see is that 7 does not go into 4. It's never going to go into 4. So what I'm interested in then, how many times would 7 go into 42? That's something you can look up on your multiplication chart. Look and see 7 times 7 is 49. That's too much. 7 times 6 is 42. Well, that would go 6 times. So I put my 6 up here because I was working with 47. So I line it up. It's important to get things lined up to keep things straight. 6 times 7 is 42. I put that down below, and I subtract. When I subtract 7 from 2, I get 5. And then I bring down the next number. Every time I bring a number down, I have to put a number up on top. I have to. So I'm going to in a second, as soon as I figure out how many times 7 goes into 53. Well, 7 times 7 is 49. 7 times 8 is 56. 56 is too much. So it must be 7 times 7. So we're going to say it goes in here 7 times. 7 times 7 is 49. Subtract, and I have to subtract, I have to borrow. 13 minus 9 is 4. 7 does not go into 4. So my remainder is 4, and instead of writing R4, I'm going to write 4 out of 7. So that's my remainder, 4 7s. And now we're going to check it, because it's very easy to make a mistake when you're doing this, so you want to always check your work. How you check it is you take the quotient, times the divisor, and then whatever you get, you add the remainder. That should give you the dividend. If you don't get the dividend, you know you made a mistake. So let's do that. Our quotient was 67. Our divisor was 7. 7 times 7 is 49. 7 times 6 is 42. Plus 4 is 46. And our remainder was 4. And I'm going to add those together. 9 and 4 is 13. 6 and 1 is 7. 473, that is what I started off with over here. So my check is just to make sure that I end up with the dividend that I started with. So I did. So I feel confident that this is my answer, my quotient. I don't think you need to rewrite this like I'm doing, but I'm just going to do it. My quotient is 67 and 4 out of 7. That would be my final answer. That check up there is not the answer, it's just a check to see if we did it correctly. And that is like number 4 on your homework page. Okay, then we're going to do, let's make 8 our divisor. Sometimes you don't get a remainder, sometimes you do, you don't know until you work the problem. Okay, 8 doesn't go into 1, but 8 does go into 16, and it goes 2 times. So 2 times 8 is 16. When I subtract, I get nothing, I get 0. So I bring down 3. Remember, every time I bring a number down, I have to put a number on top. So 8 goes into 3 0 times, so I have a 0 up here. Big mistake people make is to leave those zeros out. They bring down the 3, it doesn't go, so they just immediately bring the 4 down. If you bring a number down, you have to put a number up. It's like a balance. You got to do what same on top and bottom. Now I'm going to bring down the next number, 34. And 8 goes into 34 4 times, because 8 times 4 is 32. But 8 times 5 is 40, so 5 is too much, 4 is better. So I have 4 times 8, which is 32, and then I subtract. This gives me 2, so I have 2 out of 8 left over. Some of you may have had some fraction experience in the past, and you say, oh, can I reduce that? Don't worry about reducing, because we haven't done it yet, we're not really worried about it. I just want you to write the actual divisor on the bottom and the remainder on the top. Let's check that. We take the quotient times the divisor. 8 times 4 is 32, 2 times 8 is 16, and we add the remainder. 4, 3, 6, 1. That is the dividend that we started off with. That's how I know that that's correct. And so my answer, my quotient, is this. 204 and 2 over 8. That's a quotient. Quotient being the name we give the answer to a division problem. Okay, the next problem is written in a different format, so let's take a look at that. Something like 33,495 divided by 5. Remember, when it's written in this format, you're going to work it by rewriting in a different format first. So we have 33,495. I'm not going to bother to put the comma in here, it just kind of gets in my way. And I'm dividing by 5. You have to remember that the number on the bottom goes outside, and however you can remember that is fine. This is what somebody told me. They think of a fraction as a horse and rider, so the horse is on the bottom and the rider's on the top. And when they arrive at the saloon, the rider gets to go in to have a drink, but the horse has to stay outside. I don't know if that will help you. That helped them, and that's how they always remembered it. But however you need to remember it, the number on the top always goes under the, and the number on the bottom always stays out. That's the divisor. Okay, so how many times does 5 go into 3? None. How many times does 5 go into 33? Well, if you know your 5 facts, you know that 7 times 5 is 35, but that's too much. So it must be 6. 6 times 5 is 30. And then we're going to subtract. You multiply the number on the top times the divisor, and you write underneath, and then you subtract. So 3 minus 0 is 3, and now we're going to bring down the 4. Well, 5 times 7 is 35. That's a little bit too much again. So it looks like it's 6 again. 6 times 5 is 30 again. And I subtract, I get 4. And now I'm bringing down the 9. You don't have to put the arrows, but the reason I do it is to remind myself if something comes down, something's got to go up. What about 5 into 49? Well, 5 times 10 is 50. This is just less than that, so I think it's going to be 9. 9 times 5 is 45. 49 minus 5 is 4. And you bring down the next number. And 9 times 5 is 45, so this goes 9 again. 9 times 5 is 45. And we get 0, so we don't have any remainder, so we don't have to worry about a remainder. The check for this would be 6,699, 6,699 times 5. 9 times 5 is 45. 9 times 5 is 45, plus 4 is 49. 6 times 5 is 30 plus 4. 6 times 5 is 30 plus 3. 33,495. That was our original dividend, so that's our check. We didn't have to add on a remainder because there was no remainder. So sometimes you get lucky, you don't have to worry about that. Let me just do a quick reminder. 0 divided by 13. 14 divided by 0. One of these is undefined, and one of these is 0. Which is which? Under is undefined. 0 is not under here, it's on the top. It's the dividend, so that's 0. 14 divided by 0, now 0 is a divisor. You can't divide by 0. This one is undefined. And the other one is 0. That's two different things. 0 is definitely defined. We know what 0 is. You got $0 in your pocket, you know what that means. Empty pockets, right? Undefined doesn't mean 0, it means we don't know. It's not something we can figure out. So it's very different. Okay, and then one more long division problem with a single digit divisor. Let's try dividing by 6. And we'll go into 3, 57. The best thing you can do is to pause, try this one, come back and see if you get it right. Anyway, 6 doesn't go into 3, but it goes into 35 times because 5 times 6 is exactly 30. When I multiply that, I get 30. Subtract, that becomes 0, and I'm bringing down the 5. Because I brought 5 down, I got to put something up on top. And so the question is, how many times does 6 go into 5? And the answer is 0 times. Now I'm going to bring down the next number, and that's going to be 7. How many times does 6 go into 57? If you have your times tables out, you can look down the table and look at 6 and say, where does 6 come in, where it's just pretty close to 57. I know that 6 times 10 would be 60, and this is just a little bit less than that. I do that a lot where I check, well, what about 6 times 10? Am I close? And if I'm close, but it's a little over, I just drop down to 9. 9 times 6 is 54. 7 minus 4 is 3. 6 doesn't go into 3, so that's your remainder. So you have 3 over 6 as your remainder. The check is 509 times 6, and then add your remainder. Quotient times divisor plus remainder. That is the number that I started with for my dividend. That's how I know that this check is good, so my answer is good. Okay. And that's the division practice with single-digit divisors. It gets harder when you have double digits, and we'll spend more time on that next time. For now, let's look at some word problems. And I think I forgot to change, we just did the other one. No. Let's open the Division 1 worksheet. You can see we just did the naming and then the division problems. This is what I was telling you before. The division signs don't look all that great in here, but this is 7 into 21,064, and you can probably figure that, or 2,164, excuse me. The next thing I have on here, number 10, is to circle the words from the following list that tell you to use division to solve the word problem. And I'm just going to tell you that almost all of these are. There's only a couple that aren't. And I threw a couple in just to make sure you were paying attention. The word difference does not suggest division. What operation does that suggest? It's subtraction, right? When you see difference, you should be subtracting. So that's not one of the words. And the word product suggests multiplication, so that's not one. But if you're splitting things up, you're dividing it up. If you're finding the quotient, that's division. If things are divided, that's division. The averaged, you divide to do the average. You have to add to, but you're also finding just division is an averaged thing. If something is cut up, that's being divided. Or if something's being shared, you're dividing it. So all those words are division words except for difference and product. Okay. 6 children were each to get an equal share of their father's estate. If he left 948 acres of land, how many acres would each child get? Do you see how it says equal share? Because it's asking you to circle the word in the problem that tells you to use division and then solve. So we're going to circle equal share, or share, and then we're going to do the division. 948 acres are being split amongst 6 children. 948 divided amongst 6 people. 6 goes into 9 one time, and subtract, and bring down your 4. 6 goes into 34 5 times, because 6 times 6 would be 36. That's too much. So that's 5. 5 times 6 is 30. You're multiplying and writing it down and then subtracting. Subtracting, you get 4, and then bring your 8 down. 6 goes into 48 8 times. This is just knowing your multiplication facts. If you don't know them, have your multiplication sheet out beside you. And then that is 8. 8 times 6 is 48. And we don't have any remainder. So that means that each child gets 158 acres when they get their inheritance. Okay, so it's sharing the acreage equally among them, so we're dividing by 6. Alex needs 9-foot pieces of steel for his welding project. If he cuts up a piece of steel that is 58 feet long, we're going to say feet because that makes sense. How many 14-foot pieces will he get? Round your answer to the nearest whole number if necessary. So if you're getting some leftovers, I don't want you to deal with the leftovers, remainders. Just tell me how many pieces he'll get. So if he has a little bit left over, that doesn't give him another piece, right? He can only get so many pieces. So that should say 9 because he wants 9-foot pieces. So how many 9-foot pieces would he get if he's cutting up a piece that's 58 feet long? So we're just taking 58 and dividing by 9. There's a couple mistakes in that I fixed as we went there, right? So 58 divided by 9 because he's cutting it up. I didn't say that, we didn't circle the words, but the words are that he's cutting up. When you cut up something, you're dividing. Dividing by 9. Well, 9 doesn't go into 5. But 9 goes into 58 6 times because 9 times 6 is 54. 6 times 9 is 54. So we get 6 and 4 ninths. So we get 6 whole pieces, and then we have 4 ninths left, but 4 out of 9 left. But that doesn't help us because we need a piece that's not 4 feet long. We need a piece that's 9 feet long. So that doesn't help. So we have 6 pieces that he can make out of that, and then after that, I have some leftovers. But they don't really care about the leftovers. So your answer would just be 6. He could get 6 pieces out of this long piece of steel that he has. Number 13 has a couple of parts, so let's read it and then we'll do it. 4 families split the advertising cost of $128 for their garage sale. During the sale, they made $1,244, which they also divided up equally. So there's all kinds of words in here that tell you we're dividing. They split the advertising cost, they divided up equally. So we're interested, obviously, in circling those words. How many did each family spend on advertising? That's the first question. Well, there was 4 families and they spent $128. So I want to split that up, so I want to divide. 4 goes into 12 3 times. Bring that 8 down. 4 goes into 8 twice. So that's what they each spent on advertising. Okay? They spent $32 a piece. Let's see what else they're asking for. They also split up. How much did each family make at the garage sale? Well, they split $1,244 4 ways. So let's take a look at 1,244 split between the 4 families. 4 goes into 12 3. Bring down the first 4. 4 goes into 4 1 time. Bring down the next 4. 4 goes into 4 1 time. And there's no remainder. So they each make $312. That's the second question. And the third was, what was the profit for each family to the nearest dollar? We don't have to round here because they came out nicely. But what the profit is, we had to take the $311 and we have to take off what they paid in ads because that's not profit, that cost them. So we have to subtract those two amounts to find their profit. 11 minus 2 is 9. We borrow from the 2. 10 minus 3 is 7. And so they had $279 profit for that garage sale each. 3 parts to this problem. Remember, we had to answer 3 things: how much they spent on advertising, how much they made at the garage sale, and what the profit for each family was to the nearest dollar. Okay, top sirloin, trimmed to have only 1/8 of an inch of fat and pan-fried, has 712 calories for an 8-ounce serving. How many calories would there be in 1 ounce? So if you want to figure out, well, for 8 ounces we have 712, how much would there be for 1? There's really not a good division clue in here. And the thing about keywords is sometimes they're in there and they're obvious, like the last one, we split up, we divided up. But this one, we don't really have. How many calories would there be in 1 ounce? That's sort of intuitive, so there's no good words to circle here, and that happens. But we're talking about taking 712 calories and cutting up into 8 parts and seeing how many are in each ounce. So 712 divided by 8. What I really want you to be able to do in this assignment is to get the basic idea of dividing down. And dividing is the hardest operation, as I said. So if you're not good at it, you need to practice it. It's not like, ooh, this is something I'm bad at, I'm not going to do that anymore. You have to practice it. If you want to run a marathon, you just don't go out and run it. You have to start working out, right? And getting better and better and better at it. So you have to just bite the bullet and go in and practice these. And you'll get better at them, and all of a sudden you'll be like, oh, that wasn't so bad. And you'll realize that you've gotten good at it. So 8 goes into 71. Well, 9 times 8 is 72, and that's too much. So I think it's 8 times 8. That's 64. 11 minus 4 is 7. You know I borrowed here, so 6 minus 6 is 0. Bring down the next number, that's 2. And 8 goes into 72 9 times. 9 times 8 is 72. And so I don't have any remainder. That means that every ounce of this meat has 89 calories in it. Was it calories? I think it was. Let's reread the problem. How many calories would there be in 1 ounce? There's 712 calories in 8 ounces, and there's 89 calories in 1 ounce. So I want you to practice dividing. And so in these division problems, circle the keywords if you can find them. And if there's no keyword, you could just say no keyword. There's nothing there. You just have to kind of intuit it, what it feels like you should be doing. Okay, next time we're going to do some much harder division problems. So stay tuned, and I'll see you next time.